Okay, good morning, everyone.
Good morning,
Good
sir.
morning, sir.
Yeah, so we'll continue with our discussion on various capital budgeting techniques. Last time we had seen the payback method, which is the most simplest type of capital budgeting technique. Okay, so where we try to stress on recovering the investment as early as possible. Okay, so are you able to see the new slide?
Yes, sir.
Okay.
Yes, sir.
So this was the problem which we had discussed in the last session. Okay, and I hope the payback method is clear to all of you. Okay, like 10,000 needs to be recovered. Project A recovers it in the first year itself. Project B, if you look at 7,500 is recovered in the first year, and remaining 2,500 will be recovered in the 4 months of the second year. Okay, so that's why we write project B has the payback period of 1 year and 1 by 3, that means 4 months. Okay, likewise we find out, and the rule is the project with the least or the smallest payback period needs to be accepted. Okay, and we also could have a standard payback period. All the projects which are equal to or less than that payback period, those are only selected for evaluation for the further analysis. Okay, the projects with higher payback period than the standard payback period which is set by the management will not be taken for the further evaluation or comparison. Okay, so now we begin with what are the advantages and disadvantages of this method, payback period method. Okay, as we see here, the first one is the simplicity. So simplicity means it is very easy to understand and apply. Okay, like we had already solved a problem, so we have a fair idea that it is very simple, and that's why it is largely used today also, and heavily relied by the financial managers for appraising the investment proposals. Okay, it is also cost effective because it does not require much of the calculations and the time and the use of computers, unlike other methods, which we'll see detailed calculations are required. Then the third thing is short-term effects. Now, since it tries to recover the funds as early as possible and it gives importance to that, so we can say that in a short term, if we apply this method in a short term, we can say that our earnings per share will increase. Okay, a company can have more favorable short run effects on earnings per share by setting up a shorter standard payback period. Okay, so the rationale is that since we are focusing on trying to recover our funds or investments as early as possible, so short term effects, if we want to look into, this is the best method available. Okay, that's what we want to say here. Then the risk shield. Now, whenever we invest a good amount of money in any investment proposal, we are always uncertain about whether it is going to be successful or not. Okay, so the earlier it gives you your investment back, better it is. Okay, so we say the risk of the project can be tackled by having a shorter standard payback period, as it may ensure guarantee against loss. Okay, so since the stress is on recovering the investment as early as possible, it tries to address that thing. Okay, So if you are not concerned with the profitability, which definitely is not truly evaluated by payback period, but it stresses on reducing the risk. Basically, say suppose within first 3 years itself you recover your total investment, okay, then it is better than having some other project which is profitable than this project, but it takes even 5 years to recover the investment itself, and after that it is going to give profitability. But then because of the uncertainties present in the external world, we don't have any guarantee that the future flows will consistently keep coming. Okay, anything can happen. Okay, so that's why we say there is a good risk shield available if we use the payback method. Then the liquidity. Now this is another advantage, that earlier overcoming the investment, or earlier we are trying to recover our investments back, so we get the liquidity available which could be invested in some other better options. Okay, so here the stress is in recovering the investment as early as possible. So that aspect of this method gives you advantages of short-term effects, risk shield, and the liquidity. All these are related to that aspect of the method where the stress is given to select those projects which have the smallest payback period. Okay, I hope you understood these points.
Yes, sir.
Okay, then disadvantages, cash flows after payback are not considered. Okay, so this we had discussed in the problem. If you look at this problem, uh, here 10,000 in the project C, if you look at, there are cash flows even in the third year. Okay, but we are not going only to the third year. Okay, so this is not at all used in the evaluation criteria here. Okay, so that is totally ignored in case of C and D projects. D also is giving you 13,000 in the third year. Okay, and there are some portion of project B also which is not taken into consideration. Once 10,000 is recovered, you don't give any attention to the future cash flow. So that is not the way of evaluating the true profitability of the projects. Okay, then the another one is cash flows are ignored. That is the same thing. Payback is not an appropriate method of measuring the profitability of an investment project, as it does not consider all the cash inflows yielded by the project. Okay, considering the project, payback rule did not take into consideration the entire series of cash flows like in case of C and D. Okay, so it's one and the same point. Then the third one is cash flow patterns. Okay, so cash flow patterns, what does it say? It does not consider the magnitude and the timing of the cash inflows. Okay, if you remember, one of the points to be considered for the decision rule to select the project is that higher cash flows earlier are better than the higher cash flows in the latter part of the project. Okay, and that is related to the timing, basically magnitude as well as the timing. So this method does not give any importance to this point, isn't it? So that is one of the important points. Then administrative difficulties. Now what does it mean? A firm may face difficulties in determining the maximum acceptable payback period. Okay, means there may not be a consensus within the people in the management, or they may find it difficult to decide which should be the payback period, standard payback period with which the paybacks of the various projects need to be checked or matched. Okay, if it is more than the standard payback period, the project needs to be rejected. It will not be taken for further analysis. Okay, so that finding out the maximum payback period is basically a difficult thing as the administration is concerned. Then the last one is inconsistent with the shareholders value. This is very obvious that we are discussing till now, because in profit maximization as a goal, how it is not the objective for financial decisions, that we have already discussed in detail. Okay, because they ignore the timings uh, of the cash flows. Okay, so that is not going to increase the shareholders' wealth. Okay, if you see in a long term, it is not going to address that. Okay, so it is not consistent with the objective of shareholders' wealth maximization. Okay, so that is the last disadvantage. Okay, so now we go ahead with the next method, that is discounted payback period method. Okay, so discounted payback period method, here we try to use the present values of the future cash flows and try to find out how much time is required to recover our investments. Okay, but here again the drawback is that it does not consider the cash flows which are appearing after we have covered the initial investment. Okay, so the first 2 points, like it ignores the cash flows after payback period and it does not consider all the cash flows coming in the future. Okay, so that still remains, although we say here that time value of the cash flows is considered, but it ignores the future cash flows. So we'll take an example here. uh, Consider there are two projects P and Q. Okay, P, project P and the project Q, and the first row gives you information about the cash flows appearing in first year, second year, third year, and the fourth year, and minus 4,000 is the initial investment. Okay, and the second row is giving you what is the present values of those cash flows. Okay, say for example, for the project P in the first year, what is the value of the cash inflows we are earning? 3,000 rupees. Okay, so now 3,000 rupees which you are going to get after 1 year, what is its present value? So there is a formula here which is given. Net present value is C1 upon 1 plus K. So it is basically not net, it is present value. So by mistake it is written net. It is just a present value of an particular cash flow. So C1 is nothing but cash flow in that particular year, and K is the opportunity cost of capital. So here we are taking K as 10%. That means if you keep your money in a fixed uh, uh, FD for 1 year, you are going to get 10% as the interest rate. Okay, so that is basically opportunity cost of capital. Means if you just don't keep it invested, then you are going to lose 10%, which you would have otherwise earned by putting it in FD. Okay, so this is the opportunity cost of capital is 10%. So 3,000 divided by 1 plus 0.1, that is 3,000 upon 1.1. And since it is in the first year, you are going to get there is no raised to the power here. Okay, when it is second year, then it will be 1 plus K raised to the power 2. Okay, so you can find out if you have a calculator with you currently, the value of 3,000 divided by 1.1 will come to 2727. Okay, so 3,000 rupees which we are going to get after 1 year, its present value is 2,727. Okay, same way if we want to find out 1,000 rupees which we are going to get after 2 years as the inflow, since we invested 4,000 rupees in that project, 1,000 rupees are going to come as a profit or a cash inflow after 2 years. So it will be 1,000 upon 1 plus 0.1 raised to the power 2. If you calculate that, it comes to 826 point something. So rounding off, it is 826 rupees. Okay, so I hope you understood this present value concept. Yes.
Yes, sir.
Okay, so it is called as discounting the future cash flows, convert them into present
Yes,
values.
yes, sir.
Okay, Yeah, so this net present value, this word you just ignore, it is just the present value formula. Net present value formula will involve all the cash flows. It will come in the subsequent slides. Okay, so if you see here, project P was having a simple payback period of 2 years. Okay, and the discounted payback period of 2.6 years. Okay, so it has increased. Then Q again, first year it did not give any cash flows, and likewise, and for both them simple payback period was same. Okay, but if you see discounted payback period, the project P comes out as better than project Q because it has a lesser discounted payback period. Okay, so as a rule, the discounted payback period is always going to be greater than the simple payback period for particular project, because we are discounting the future cash flows, so it is going to increase your payback period. Okay, so here 4,000 which we are going to get for Q in the second year. How do you find out 3,304? Here C1 equal to 4,000 divided by 1 plus 0.1 raised to the power 2. That's going to give you 3,304. Then 1000 divided by that remains same here. Then 2000 divided by 1 plus 0.1 raised to the power 4. Okay, that gives you 1366. Okay, and then the formula remains same. 4000 को cover करने के लिए first year 3,304 rupees have been covered. Then next year it is 751. So sorry, this is first year 0, second year is this, and third year 9 months are required to cover that remaining 694 rupees, 696 rupees. Okay, so that becomes 2.9 years. Okay, so that is a simple formula which we had used for the payback period. I hope it is clear to you, discounted payback period. Yes.
Yes, sir.
So yeah. So the advantage remains almost the same, except it takes into consideration the time value, but it ignores the all future cash flows and the cash flows after payback period. Okay, so still it suffers the similar type of limitations as we had seen in case of simple payback period. Okay, so now going ahead, this will be the next method, and this is one of the uh, best methods available to evaluate the investment decisions. Okay, so net present value method is the name of that. Cash flows of the investment project should be forecasted based on realistic assumptions. So this is the first step in every investment decision. That is going to be the first stage, that you need to predict what is going to be the cash flow in the first year, second year, third year. Okay, so there are a number of chapters after this which deals with how to find out opportunity cost of capital, that percentage using which we discount, and how do you predict the cash flows, what are the factors affecting those. Okay, so all those things are discussed in the book, but since it is not in our syllabus purview, we are not going to discuss that. Okay, so in any investment decision, the first step is going to be the prediction of cash flows going to come in the future years. Okay, forecasting them. Then appropriate discount rate should be identified to discount the forecasted cash flow. So that is what I was telling you, that interest rate basically. So we are taking it a value of 10%, but how did it come? So that is also another thing to analyze, and that is to be properly found out so that we can get a true profitability. Okay, so that is nothing but opportunity cost of capital. Then present value of cash flow should be calculated using the opportunity cost of capital as the discount rate. Okay, so this is the third step. There is a formula which will come in the next during the example. We'll see that net present value using the cash flows and the opportunity cost of capital. Okay, and the project will be accepted or rejected based on this decision rule, that net present value should be positive. It should be greater than 0. If it is negative, then it is going to give you loss. It will not give you profit. Okay, that means whatever is the present value of the investment, that is how much we have invested, that is more than the net present values of all the future cash flows which will be generated by that project. Okay, so then why should we unnecessarily waste our time, energy and money in such a project? Okay, so only those projects will be taken for further evaluation which are going to give you some positive net present value. That means some profit over and above our capital which we have invested. Okay, so this is a formula. Like net present value should be found out by subtracting the present value of the cash outflows from the present value of the cash inflows. Okay, so present value of the cash outflow is obviously going to be the current year investment which we are doing. Like in previous examples, 4,000 rupees was the initial investment, so that becomes the net present value of the cash outflows. Okay, and all the future years whatever inflows are there, they are going to be converted into net present values or present values, and they are going to be added. Okay, and the difference will be found out. Okay, so this C1 is nothing but the cash flows in the first year divided by 1 plus K. That is, K is nothing but opportunity cost of capital or the rate at which we are going to discount. Then second year cash flow C2 divided by 1 plus K raised to the power 2. Okay, so as you go ahead increasing the number of years, this power will go on increasing. Okay, so can you write down this? Just simply note down this in your notebook. Next example will be using this formula. C1 upon 1 plus K plus C2 upon 1 plus K whole square plus C3 upon 1 plus K cube plus so on up to Cn upon 1 plus K raised to the power n minus C0. C0 is nothing but the value, present value of the cash outflows. Okay, done. So this is a problem here. Assume that the project X costs rupees 2,500 rupees now, that is the current year, and is expected to generate year end. Year end means the at the end of the first year, at the year of end of the second year, at the end of the third year. Okay, so end of the year figure formula will be different. In the beginning of the year figure, if we consider, then the formula will be different. So that we'll discuss in the future sessions under the time value of the money topic. So first year it is going to generate 900 rupees at the end of the year. Then second at the end of the year 800 rupees. Third year 700 rupees. Fourth year 600 and fifth year 500 rupees. Okay. So opportunity cost of the capital is given as 10%. Okay. So basically opportunity cost of capital means every year your capital will grow by 10%. Okay. 10% of the year end figure of the previous year. Fine. So the formula, as we already taken down, you just calculate this and just find out whether you get this value or not. 900 divided by 1 plus 0.1 plus 800 divided by 1 plus 0.1 raised to the power 2 plus third year's figure is 700 divided by 1 plus 0.1 raised to the power cube and 600 by 1 plus 0.1 raised to the power 4 plus 500 divided by 1 plus 0.1 raised to the power 5 minus the present value of the cash outflows, that is 2,500. Okay, so quickly find out and just tell me whether you get 2725 as the net present value figure. Okay, I will tell you what is that PVF, that is present value factor. I will tell you what exactly that means. Done?
Sir, 1 minute.
Or you can just check whether you are getting 0.909, 0.826, 0.751, 0.683 and 0.620. Okay, so these are nothing but the present value
Yes, sir.
factors. Yeah, fine. So I hope you understood. Now you just quickly solve another numerical, a simple numerical involving only 3 years cash flows. You write down initial investment is 16,000 rupees. Initial investment is 16,000 rupees, 16,000. Cash flows in the first year is 8,000 rupees. Second year 7,000 rupees. Third year 6,000 rupees. And the opportunity cost of capital is 20%. Okay, understood
Yes.
the problem? You can
Yes.
quickly tell me what is the net present value of this project, whether it is positive or negative. Done? What is the net present value? Is it positive or negative?
Sir, it is positive 25,833.
Positive. I think you have not taken 0.2 as the discount rate. Don't take 0.1. If you take 0.2, is there anyone else who has solved the problem? Anyone else is solving? Saili,
Yes, sir.
Rohan, Ritvik, Pawan, Namrata, Rushikesh. All of you are getting positive value. I am telling you, don't take 0.1 as the discount rate. It is 20%. See, it is simply 8,000 divided by 1.2, then 7,000 divided by 1.2 raised to the power 2, plus 6,000 divided by 1 plus and that is 1.2 raised to the power 3, and this whole figure needs to
Sir,
be subtracted from
12,499. It is negative.
negative. The value is minus 1004 rupees. I think you are doing some mistake in calculation. The first factor is 0.833, that is 1 upon 1 plus 2 is 0.833, 1 upon 1 plus 2 raised to the power 2 is 0.694, and 1 upon 1 plus 2 raised to the power 3 is 0.579. Okay, so when you subtract this from the original investment, it comes out to be negative 1004 rupees. So will you accept this project at this discount rate?
No, sir.
We will not accept because it is not a profitable venture. At the end of the 3 years, we are going to incur 1004 rupees as the loss. So why should I invest money for 3 years? And instead of earning at the rate of 20%, whatever I would have earned, now I am basically losing my money, depending on the cash flow patterns which this project is giving me. Okay, it should be greater than 8,000, 7,000, 6,000 if I want to be profitable. Okay, so we'll see some more problems in the subsequent sessions once we discuss all the methods. Okay, so let us now we go through the advantages, disadvantages, and the acceptance rule. So acceptance rule is basically, we already discussed that if the project is having positive NPV, accept. If it is negative NPV, reject. If it is equal to 0, then may accept the project. Then the NPV method can be used to select between mutually exclusive projects. The one with the higher NPV should be selected. Now, mutually exclusive means we had already discussed there are two projects which are competing with one another. Okay, like example, we had discussed that if we are going for a capital intensive automatic manufacturing setup and a labor incentive semi-automatic manufacturing setup. Okay, so both of the things are an investment project. Okay, so both of them will be evaluated. We are not going to put money in both because they are going to serve the same purpose. Okay, only difference is semi-automatic and automatic. One is going to require more money, another is going to require more labor. So its operating cost will be more. Here operating cost will be less, but initial investment of the capital is more because it is fully automatic. Okay, so now within these two projects, if you want to decide, then you find out the net present value of both the projects. Whichever is higher, that project you will select. Okay, simply finding out the NPV, we get this. Okay, if it is negative, one of the project is having negative NPV, right away it is rejected. Okay, it is not even used for further comparison or analysis. Okay, and these are the advantages and disadvantages of this method. Like the first one is it considers the time value, okay, and the magnitude. Okay, these are the two important things. It gives uh, importance to the time value. It doesn't consider, suppose if you get 1 lakh rupees after first year and the second year as the same, because we are going to discount them with the help of opportunity cost of capital, then it is a measure of true profitability. Okay, so it is measure of true profitability because it uses all cash flows occurring over the entire life of the project in calculating its worth, which was not seen in the previous two methods. Hence, it is a measure of the project's true profitability. NPV method relies on estimated cash flows and the discount rate rather than any arbitrary assumptions or subjective considerations. Okay, so it is, that's why it is called as the measure of true profitability. Then this value additivity is another important advantage. What does it mean? It allows the projects to be independently evaluated. Okay, and suppose they are independent to one another. There are 3-4 projects which can simultaneously looked into and invested into. Okay, so the NPVs of those projects can be simply added as a simple summation. Okay, so the discounting process facilitates measuring cash flows in terms of present values, that is in terms of equivalent current rupees. Okay, so everything is converted into the rupees. Therefore, the NPVs of the projects can be added. For example, NPV of A plus B together is nothing but NPV of A plus NPV of B. Okay, this is called as value additivity. Hmm. Then the uh, shareholders value. So this method is in uh, line with addressing the maximization of the shareholders wealth. Okay, so this is one of the methods which if we apply, it will result into selection of those projects which are going to ultimately improve or increase the shareholders wealth. Okay, now the limitations are the cash flow estimation. The NPV method is easy to use if forecasted cash flows are known, okay, which is not the case generally. Okay, and that is not the case with any of the methods. In practice, it is quite difficult to obtain the estimates of cash flows due to uncertainty. So how do we do that is discussed in the subsequent chapters. That is a part of, say if you take MBA in finance domain, you will go deep into all these things. Okay, so since we are just trying to get ourselves exposed to financial management, we are not having those things in our syllabus. Okay, so it would lead to an 100 marks complete theory paper on financial management, and costing will be another subject altogether. So here we are combining two things, financial management and costing. Costing is in the second unit, financial management is in the first unit. Okay, so we have certain limitations. So there are methods to predict, forecast this cash flows with certain accuracy that is discussed in the subsequent chapters. Then the discount rate, it is also difficult to precisely measure the discount rate. Okay, isn't it like if, just now we had taken 20%. Now why? What is the reason of taking 20% or 16%, 17%? So that needs to be explained. Okay, there we are just trying to understand the concept theoretically, but when we uh, practically want to do that, you should be aware that what is the discount rate at which I should discount my future cash flows. Okay, so obviously it keeps varying, like the interest rates given by the banks keep on varying, and for different needs they are different. If you use a personal loan, it is higher than if you want to go for a home loan. If you want to take it for working capital needs, it will be different than if you want to take it for a longer term. Okay, so these are all things to be considered. This interest rate is not simple thing to decide. Then mutually exclusive projects, in the case of mutually exclusive projects, if they are having different time frames or unequal lives, then this NPV rule may not give unambiguous results. Okay, and the ranking of project is also difficult if you change the discount rates. It has been seen that if the discount rates are changed, the ranking of the projects also changes. Okay, uh, like the project ranking is reversed when the discount rate is changed from 5% to 10%. Okay, so it may happen because of the cash flow patterns. The impact of the discounting becomes more severe for the cash flows occurring later in life of the project. Okay, because if you have noticed in the formula, there is an uh, raising, like denominator. If you look at, there is raised to the power 1, then raised to the power 2, raised to the power 3. It goes on increasing like that. Okay, so the effect of discount is going to increase as you go uh, in the future more. Okay, so higher the discount rate, the higher would be the discounting impact. In case of larger cash flows, if they are coming later in the life, that will give you different picture. If the larger cash flows are coming in the initial period of the life. Okay, so these patterns are going to create problems if you change the discount rate. Okay, if you change it from 10 to 20%, you may get a different ranking altogether. Okay, so these are certain things which you need to keep in mind. Okay, so we end here. Now next session we will discuss the other two remaining methods, like internal rate of return and the accounting rate of return. So internal rate of return is another capital budgeting technique which considers the magnitude and the timing of the cash inflows. Okay, so the concept is that it tries to find out that rate at which uh, the total inflows, present value of the total inflows equals to the present value of the cash outflow. That means no profit, no loss. So what is that rate? So that is called as the internal rate of return. Okay, so we'll see that, and there is an accounting rate of return, uh, the last method. So once we complete these two methods, then we have completed the major portion of this unit.